Did you know plants don't eat garbage? So stop throwing banana peels directly onto the soil, because they don't work like that. The right way is to process them so they actually release their potassium. First, chop all your banana peels into very small pieces. The finer they are, the better. Place them in a clean container and add water. Now, squeeze 2 lemons into the mixture. The citric acid helps extract the potassium inside the peel. Let the mixture sit for at least 48 hours. After that time, you'll notice fermentation. That ferment not only contains released potassium, but also beneficial microorganisms. Dilute this concentrate in 1 gallon of water, strain it well, and apply it to your plants. You can pour it at the base or spray it onto the leaves. Spraying is especially useful because these microorganisms can help fight leaf diseases while repopulating your soil with good microlife. This is how you actually use banana peels properly and help your plants grow healthier. This is the wrong way to use eggshells on your plants. If you just throw crushed shells on the soil, the calcium inside won't actually nourish your plants. That's because the calcium in eggshells is calcium carbonate, a very stable form that takes a long time to break down. However, there's a much better way to make it work. Crush the shells very finely until they turn into a soft powder. The finer, the better. Then, place the powder in a clean glass and add lemon juice or white vinegar. Right away, you'll see a chemical reaction. Bubbles forming as the acid begins to dissolve the calcium. This happens because the lemon's acidity converts the calcium carbonate into calcium citrate, a form that's far more soluble and easier for plants to absorb. Let this mixture sit for at least 4 hours to finish the reaction. Then dilute it in 4 liters of water and apply it directly to your plant's base or leaves. That's how you turn simple eggshells into a natural, soluble calcium fertilizer, giving your plants the nutrients they can actually use. The most common mistake many farmers make is applying agricultural lime and believing plants will absorb calcium instantly. In reality, the calcium in lime is not directly available to roots. To make it truly soluble and useful, you need to mix it with fresh lemon juice. At that moment, an effervescent reaction takes place. The low pH of the lemon interacts with the high pH of the lime, neutralizing each other. With this method, you not only balance soil pH but also transform calcium into a soluble and plant-available form, making it easier for your crops to absorb and benefit from it. Did you know that if you place eggshells in a container, crush them into a fine powder, and then mix them with lemon juice or citric acid, something magical happens. The acid reacts with the calcium carbonate in the shells, releasing carbon dioxide bubbles and transforming the calcium into a form that plants can easily absorb. Calcium citrate. Why is this important? Because calcium carbonate, as it is in the shells, cannot be absorbed by plants. But when it becomes elemental calcium and calcium citrate, it turns into an available nutrient that strengthens plant cell walls, promotes healthy growth, and prevents diseases like blossom end rot in tomatoes and peppers. Plus, it's an eco-friendly and cost-effective way to recycle a waste product that would otherwise end up in the trash. So, next time you use eggs in the kitchen, save those shells. With a little lemon and patience, you'll be creating a natural fertilizer that your plants will thank you for. It's science and sustainability in action. The most common mistake people make is throwing fruit peels directly onto the soil, expecting them to immediately provide nutrients to plants. While it's true they eventually decompose, the process takes a long time and plants can't access those nutrients right away. The correct way to use them is through composting, or if you need a much faster fertilizer, by finely grinding the fruit peels and other organic scraps, and then mixing them with a natural acid like lemon juice. The lemon helps release and dissolve the nutrients trapped in the organic waste, making them soluble and easy for plants to absorb. This mixture should rest for at least 24 hours. During this time, you'll see how the peels become completely soft thanks to the acid. After 24 hours, it's very important to balance the acidity by adding finely ground eggshells or agricultural lime. This neutralizes the pH and makes the fertilizer safe and effective. Once ready, you can apply it directly to your plants, either into the soil or as part of a nutrient-rich irrigation. In yesterday's video, we planted one lettuce with a fish and one with chemical fertilizer, and it went viral. But many of you commented, "Where's the absolute control?" Or, "Why only one pot per treatment?" So today, I improved the experiment. First, I prepared 3 pots with buried fish. Same amount of soil, same type of lettuce, all planted under the same conditions. Then, I prepared 3 more pots with chemical fertilizer, using the same setup to compare fairly. And finally, I said, let's add something extra. What if we grow lettuce without any fertilizer at all? So I prepared 3 more pots, same soil, same water, same lettuce, but no fish and no fertilizer. That's our absolute control, and it's key to understanding how much each treatment actually helps. So now we have 9 pots, 3 with fish, 3 with fertilizer, and 3 with nothing. Thanks to your feedback, this experiment is more complete and more reliable. Now the question is, which one will grow better? Natural fish, chemical fertilizer, or nothing at all? What happens if you fertilize lettuce plants with recycled batteries? A few weeks ago, we started this experiment to see what would occur when plants were directly exposed to batteries. It is often said that batteries are among the most dangerous pollutants on Earth, and that a single one can contaminate the water of an Olympic-sized swimming pool. To test this, I planted 3 lettuce plants in pots where I placed broken batteries at the bottom so their roots would come into direct contact. At the same time, I planted 3 control plants in identical pots, under the same conditions, but without any batteries. For the first 2 weeks, there was no visible difference. All plants grew in the same way. However, after 7 weeks, the results became very clear. The battery-treated plants looked dry, yellowish, and severely weakened, while the control plants without batteries remained healthy, green, and strong. It is important to note that all plants received the same watering, the same fertilizer, and identical conditions, so the only difference was the presence of the batteries. There are 3 reasons why some plants bloom after a nail is inserted into their stem, and although it may sound strange, this phenomenon has a fascinating scientific explanation. The first reason is related to physiological stress. When you insert a nail into the stem, the plant interprets it as a threat. In response, it activates defense mechanisms, including the production of ethylene, a hormone that accelerates ripening and flowering. It's like a final effort to reproduce before dying, a survival strategy commonly seen in nature. The second reason involves ionic exchange. Nails, especially if made of iron, can release small amounts of this element into the plant tissue. Iron is essential for chlorophyll formation, but it can also disrupt the plant's nutrient balance, triggering hormonal changes that promote flowering. And the third reason is more symbiotic than aggressive. The wound caused by the nail can allow beneficial microorganisms from the environment to enter. This activates the plant's immune system, which in turn may stimulate certain genes associated with flowering.
Did you know that you can easily make an iron-rich homemade fertilizer using just rusty nails and other scrap metal? This simple, natural method involves collecting old iron materials, placing them in a container, and adding an acidic solution like lemon juice or vinegar. These acids react with the oxidized iron, transforming it into a form plants can easily absorb, promoting greener, stronger, and more productive growth. However, not all metal-based gardening hacks are beneficial. Many believe that burying copper coins will fertilize plants, but this is a misconception. The metallic copper in coins oxidizes very slowly and isn't in a form that plants can readily absorb. Furthermore, coins often contain other metals that can contaminate your soil if used excessively. Even more critically, an alarming practice is burying household batteries in the soil. Our experiments have shown that batteries rapidly leach toxic chemicals and heavy metals into the surrounding environment, polluting the soil and water and posing a significant, invisible threat to your plants and the entire ecosystem. Choose appropriate fertilizers and always prioritize.
You're fertilizing your plants by just throwing crushed eggshells into the soil. You're doing it all wrong. Eggshells are not an immediate fertilizer. While they do contain calcium, it's in the form of calcium carbonate, which is not easily absorbed by plants. But there's a way to make that calcium truly useful. First, wash and dry the eggshells thoroughly. Then crush them using a mortar and pestle until you get a very fine powder. The finer the powder, the better. Next, place that powder into a clean container and add fresh lemon juice. You'll immediately notice a fizzing reaction. That's effervescence. This happens because the lemon is acidic and the eggshell is alkaline. The acid reacts with the calcium carbonate and transforms it into calcium citrate, which is much more soluble and absorbable by your plants. The fizzing you see is carbon dioxide gas being released, a sign that the calcium is being unlocked. Let this mixture sit for at least 12 hours and then it will be ready to use. Now you can apply this liquid directly to the base or leaves of your plants, delivering soluble calcium that they can absorb quickly and efficiently. This is the right way to use eggshells to fertilize your garden.